Hey, what's up guys? Hope you're doing well. I'm Marvin from Precision Data Science. In this video, we're going to be dealing with a multi-class problem that is classic iris dataset. In this dataset, we have 150 flowers belonging to 3 categories, and we're going to be using the logistic regression algorithm for this multi-class problem. So without further ado, let's dive into the video. So first we're going to be importing the NumPy and pandas to work on the array data and the data frame. Next we have matplotlib and seaborn for data visualizations. And then we have warnings to ignore the warnings and have cleaner output. We're going to read the CSV using read_CSV and assign it to our data frame df. Next with shape method we can see the number of rows and columns. Here we have 150 rows and 5 columns. And head and tail method is going to display the top 5 rows and the bottom 5 rows of the dataset. So for the top 5 rows we have sepal length, sepal width, petal length, petal width, and the variety belonging to setosa. And on the bottom 5 rows we have data belonging to virginica. So basically these are the characteristics of the flowers belonging to different varieties such as setosa, virginica. And we're going to see how many classes are there. Next, info method is going to show us the number of entries, that is 150, and non-null counts, that is non-missing data. Here we have 150, which means that we don't have any missing data, and also the data types. Here we have float data type as well as object data type. With the n-unique method, we can see that the sepal length, sepal width, petal width, and variety, we have diverse data. However, for the variety, it is constrained to only 3 values. Since it's an object data type, we have only 3 values. And since we have the float data type, we have diverse numbers for the sepal length, sepal width, petal length, and petal width. Now for this variety, we're going to check the unique values that we have in this data set. So we're going to pass in the unique value for the variety column. And we have setosa, versicolor, and virginica as the 3 varieties of flowers which we have in the data set. And the data type is object data type. Now since we have these 3 varieties, we're going to check how many values are there belonging to these 3 classes. So for that we're going to run the value counts. And we can see that there are 50 out of 150. We have 50 belonging to setosa, 50 belonging to versicolor, and 50 belonging to virginica. So basically the data set is equally distributed and perfectly balanced. Next, since we have the object data type for the variety column, we need to convert this into numerical data, because for the machine learning model to work, we need numerical data and not the object data types. For that, we're going to use the label encoder, try to convert the object data type into the numerical data type. First, we're going to import the label encoders from the scikit-learn library. We're going to instantiate it and then fit transform for the variety column. That is the column which we have object data type. After fitting, now we can check the unique values. And here we have 0, 1, 2. So earlier we had setosa, versicolor, and virginica, and now we have 0, 1, and 2. So basically the object data type have been converted to numerical data type as class 0, class 1, and class 2. Now in order for the machine learning model to work, we need to consider features and the targets. For the feature, we are considering all the columns except the variety column, and for the target column, we are going to consider the variety column. Next, we are going to quickly look at the features and the target. For the features, we have sepal length, sepal width, petal length, and petal width. And for the target, we have the class, that is from 0 to 1. Next, for the machine learning model, we're going to split the data into training set and testing set. For that, we're going to import the train test split from the scikit-learn library, and then we're going to split the data into xtrain, xtest, and ytrain and ytest. So here we are considering 20% for the test data and 80% for the training data with a random state of 157. So after splitting the data, now we are going to see how the classes are distributed for the training data. So we can check it with value counts, and we have 40 belonging to each classes. So again, it is perfectly balanced. In order to run the machine learning model, we may have certain features in the features column which may vary from 0 to 1 or maybe even negative value, and some features may vary from 0 to 100. So there is a quite imbalance in the scaling of the data. So in order to run the machine learning model, we need to bring down the scale to a normalized manner so that the machine learning model is going to give equal weightage to each of these features and try to learn. Next, just for verification, we can check the scaled data for the xtrain with the describe method. Here we can see that the mean is almost 0, 1e minus 16, 1e minus 15, 2 into e minus 17. So all are almost 0, and the standard deviation, as we have seen, it should be 1. For all this we have 1. Next, we are going to implement the machine learning model. So in this case, we are using the logistic regression, which is again a classification model, and it is going to classify based on the input data. Here the logistic regression will be using a probabilistic model, and it is going to use softmax function for predicting the probabilities. We're going to import the logistic regression from the scikit-learn library, and then we are going to instantiate it with a random state 157. After instantiating, we are going to fit for the training data. Here, based on these values from the xtrain or the features, it is going to learn how to predict the ytrain values. Now, after machine learning model learns from the training data, we are going to predict for the xtest. For the xtest, we are going to predict using the logistic regression model, which has already learned from the xtrain and ytrain, and we are going to assign it to the ypred. Next, we have the ypred as the predicted values, and the actual values we have ytest. For these two comparison, we are going to import certain metrics from the scikit-learn library, such as accuracy score, F1 score, classification report, and the confusion metrics. So the classification report is going to show us the precision, recall, and the F1 score for each classes, for class 0, for class 1, and class 2. And the F1 score is basically the harmonic mean of precision and recall. Next comes the accuracy. The accuracy of the model is 96.67, and the macro averaged F1 score for the ML model is 96.66, which is represented here. Accuracy is represented here, and F1 score, macro averaged F1 score is represented here. So here we are taking macro average because we need to make sure that the F1 score is mean of all the three classes and not reflecting only one class. Next, for the confusion matrix, we are going to plot the heat map and see for better visualization. And here we can see the visualizations. All the classes have been predicted perfectly except for the versicolor, where one has been misclassified for the type 1 error. So next, since we already verified our machine learning model and we are able to get good accuracy, that is 96.67%. As an additional step, we are going to test on a random sample. In order to test on a random sample, since we have xtest as a numpy array, we are going to visualize it using the data frame method both for X test and the Y test. Here we have the first 5 rows of the dataset for the X test, and for the target we have first 5 rows. Next we're gonna check for a random index. Let's say for example we'll take 2, that is this one, and we're gonna test it. First we're gonna select the random index as 2. You can take any other values, and we're going to reshape the X test in order for the machine learning model to fit it, and then we are going to predict the logistic regression on this random data point. After predicting, we are going to assign it to a variable prediction, and for the same random index we are going to select the corresponding Y test value using iloc method. Next we are going to print the parameters for the given random index, and we are going to compare the predicted label and actual label. If we run this, here we have 0.8, which is again the second one, 0.8 minus 0.57, 0.48. Same here, minus 0.57, 0.48. So the predicted label is 1 and actual label is 1. As you can see here, the predicted label is 1 and the actual label is 1. So next we are going to check on a different value. Let's go with 4. So for 4 we should be getting how much? 0, 1, 2, 3, 4. We should be getting 2. Let's run this. As you can see, we have predicted label as 2 and actual label as 2. Again here we have predicted label as 2, actual label as 2. Here for the fourth random index we have 2.2 minus 0.1, 1.34 and 1.49. Similarly we have the same value, 2.27 minus 0.1, 1.34 and 1.449. So these are the features. For these features the predicted label is 2 and the actual label is 2. So since we have this accurate data, we have tested on a random sample and we have made the prediction, we have plotted the confusion matrix, and we have checked the accuracy and the F1 score. Also we plotted the classification report, which is again very good. Since it's a small data set or a classic data set, we are able to predict well. And this way the logistic regression algorithm or the machine learning model can be used for predicting multi-class problems as well. So that's all I have today. If you enjoyed this video so far, please like the video, subscribe and hit the bell icon to see more content. Thank you.